Chapter 6, Section 4, we're going to talk about translations of graphs of sine and cosine. So first we'll look at horizontal tangent. So remember, when you have a function, it moves left and right, up and down, stretches and shrinks. So what we talked about last time in the last couple of videos, Section 3, was how the graph stretches or shrinks based on our a, or if we have our period length, it stretches horizontally, right? So today we're going to look about some translation, so moving left to right or moving up and down. And so that's when we're going to add something to our function at the end, or subtract something from our function at the end, or we move it left and right, and that's a horizontal translation. So anytime that we have a function, any trig function really, so y equals any trig function, so I'm going to write the word trig here, but that could be substituted for tangent, cotangent, cosecant, secant, whatever have you. And that's taking a trig function of b times x minus d. And then we add something at the very end. So what's inside here is going to move it left and right. So what's inside here is going to move it left and right, and this one's going to move it up and down. So we're going to talk about horizontal translation first. So we're going to talk about this one. There's our b. Sometimes you'll see that b distributed, so it might look like bx minus, say, p. I'm just doing a different letter because I'm multiplying b by d, and that has to do with our phase shift, how our graph moves left and right. All right, so what I normally do here is it's pretty simple. All we do is normally just set what I'm taking the trig function of, bx minus d. I set that equal to, or there'd be parenthesis here, or sometimes that b is distributed. So I set what I'm taking the trig function of, and I set it equal to where the normal start of the trig function. And so sine and cosine start at 0. So I'm going to set always this equal to what I'm taking the trig function of equal to 0 for sine and cosine. And then really all of them start at 0 except for tangent. Tangent starts at negative pi halves, so we set it equal to negative pi halves. All right, so that's how we're going to do this, and that's how it moves left and right. So whatever this equals, it's going to move it left and right. All we do is just solve for x here. So we just solve for x. Okay, and that's going to tell us where we normally start from. And so what we'll do is just move to this, to whatever this x is, and then we'll do our graph the same. So what I like to do is most sine looks like this, right? So all I do, instead of starting at 0, I just start out whatever this x is, and then I just change my intervals. That's all I do, so my graph looks the same every time. All right, so here's an example. So my period for sine normally is 2 pi. So I divide that by b. My b is just 1. What's either being multiplied by x or what's on the outside here, right? And if there's something on the inside here and on the outside here, then we need to multiply that to get our b, okay? All right, so it is 1. Oops. So it is 1. So it's just still 2 pi. And then our interval, I'll explain later, but let's go ahead and do the interval length. So that's taking 2 pi and times it by a quarter divided by 4. So that equals 1/2 pi. So we're going to count by 1/2 pi, and we're going to start at 0. So what I mean by interval is where we normally start. Sometimes I do set the inside equal to where we start, and sometimes I set it equal to where we start and where we finish. So that's what I mean by interval, is where we start and where we finish. That's what I mean by interval. But really all you have to do is the where we start. So I add pi thirds to both sides, so x equals pi thirds. So that's where I'm going to start. So instead of starting at 0, I'm going to start at pi thirds. Now I just add my interval length, which is 1/2 pi. So here I just got to make sure I have the right units, right? So I need the same units. So I got to switch this one. Instead of pi thirds, it's going to be 2 pi sixths. And this one, the interval length, would switch to, multiply both sides by top and bottom by 3, so we get 3 pi sixths. And so I take where my start, add my interval, so that's 5 pi sixths. So that's, add another 3 pi sixths, so that's 8 pi sixths. And 9, whatever, 11 pi 6. There we go. So that's 1, 2, 3, 4, one more. So somewhere out here, that'd be 14 pi 6. And I don't care if you reduce these. If you want to reduce them, you can. You don't have to. So I could check that distance in between 11 pi 6 and 6 pi 6, or 2 pi 6 and 14 pi 6 is 12 pi 6, which is 2 pi. All right, so then I graph sine. Well, sine normally starts out at 0, then goes up to 1, then goes back to 0, then -1, and then back to 0, right? And because I don't have an a, this number's not going to change. It's going to stay at 1 and -1. Okay, and there's nothing being added to the end, so it's not going to move up and down. All right, here's another example. I'll do it real quick. Try. So 2 pi, again, divided by b. Our b is 1. There's nothing being multiplied by the x, so it's just still 2 pi. Interval, I set what is I'm taking the trig function of and set it equal to where we normally start, and that's at 0, so the x equals negative pi fourths. So instead of starting at 0, I'm going to start at negative pi fourths. Then I find my interval length by taking my period and dividing by 4. So again, that's 1/2 pi. So again, I can get common factors here. Just multiply both top and bottom by 2. So I get 2 pi over 4. So I should have probably left it like that. So there's my interval. So I add negative pi fourths plus 2 pi fourths is 1 pi fourth. Another pi fourth is 3 pi fourth. Another one is 5 pi fourth. And 7 pi fourth. Okay, then I go ahead and graph cosine. Cosine, the y values of cosine are 1, 0, -1, 0, back to 1. So it looks like this. Now I just take those y values, 1, 0, -1, 0, and 1, and I times them by my a. My a is 3, so that becomes 3, 0, -3, 0, 3. So all I have to do is really just change this value to a 3 and this value to a -3, and I'm done. All right, so here's a little bit different, and my writing here is a little bit off here with the b and the d thing. It doesn't really matter. Just take what you're taking the trig function of and set it to wherever you start, no matter how complicated it looks, and that'll help you. The only thing partly is your period, which really you don't even have to figure out your period right away, really. Actually, you do to find interval length, sorry. So set it equal to 0, so subtract pi, so I get 3x equals negative pi divided by 3, so negative pi thirds. So that's where I'm going to start, is negative pi thirds. Then I'm going to have my 4 intervals. Okay, and then my interval length, I need to find my period, right? It's my period divided by 4. So here's where it's a little more complicated, but not too bad. Here I kind of already, the b is already distributed, but yet I'm using the same letter here, so maybe that's confusing. Sorry about that. But b is whatever's being multiplied by x, either on the inside or on the outside. So our b is 3. So I'm going to take our normal period of cosine and divide it by our b, which is 3. So there's my period. And now for my interval length, I'm going to multiply that by 1/4, or divide that by 4. And that reduces. Maybe you don't want to reduce it because then you can get a same common factors, but it's pi over 6. So I need to change this one to -2 pi over 6. So I have common denominator, so I can add. So a -2 pi 6 plus a pi 6 would be a negative pi 6. Plus another pi 6 would be 0. Plus another pi 6 would be 1 pi 6. And then 2 pi 6. And we can see that is a distance of 2 pi thirds. Right? If I multiply this by top and bottom by 2, I get 4 pi over 6. And then if I take -2 pi 6 and I add 4 pi 6, I would get 2 pi 6, which gets me to my end. Okay, so normally cosine is 1, 0, -1, 0, and back to 1. So it looks like this. I multiply those numbers by my a. So right now I have a 1 and a -1 and a 0. So if I just multiply those by a, which is -2, then this first one would be -2, and this would become a +2 down here. So which means, because that negative, it flips it, right? So it flips it. So what I'm going to have to do is I'm going to have, I'm going to go ahead and have to flip it. Oops. Okay, so I'm going to have to flip it. Oops. Jeez. Okay, so I'm going to have to erase this. Erase erase this, erase that, and I want it to flip it. So it's going to go -2, 0, +2, 0, -1. So I have to erase these because that negative out front flipped it. So it's going to look like this. Okay, and so that's how that goes. All right, let's go ahead and add a C here. So now we're doing a vertical translation. Okay, so we're moving it up 3. This is a +3, so we're moving up 3. We still have a -2 out in front of our cosine, so that means that's our A, right? So it's going to be flipped. It has a negative, and it's cosine. 1, 2, 3, 4. Okay, and our period is dividing by our B. Our B is just right there, 3, so it's 2 pi thirds again. So that means this is 2 pi over 3 times 1/4. The 2's are going to cancel with the 4, so we get pi sixth. So there's our interval length. Where we start, we set what we're taking the cosine of equal to 0, so we're still going to start at 0, and we're going to add pi sixth. So pi sixth, 2 pi sixth, 3 pi sixth, and 4 pi sixth. And we can see that is a distance of 2 pi thirds. Okay, so now cosine, these are going to be multiplied. Here are my y values, 1, 0, -1, 0, and then back to 1. And I'm going to multiply them all by -2, so that's -2, 0, +2, 0, -2. And then the very last thing, now I can add my c. And sometimes it's at the beginning, sometimes it's at the end. So I'm going to add 3. So I'm going to add 3 to this. So that's going to get me 1. I'm going to add 3 to this. So that's going to get me 3. Add 3 here. I'm going to get 5. Add 3 here. I get 3. Add 5 here. I get 1. You notice that it still repeats the same pattern. 1, 1, 0, 3, -1. It's the opposite of this. 5, 0. So you notice these zeros are the same. These two zeros are the same. These two numbers are the same. This is a 1. This is a 1. You notice that these two numbers are the same. So are these two numbers. Okay, so it kind of still has that same pattern. The only one that changes is kind of that middle one. All right. Okay, so now we can go ahead and graph those numbers. So we had down here. So normally cosine looks like this with the negative out front. It looks like this. Okay. Well, guess what? All I'm going to do is just change my y values. So I had my y values. They were 5 was the biggest. The middle number was 3, and the smallest number was 1. So I just changed these y values. So instead of 1, +1, 0, and 1, it became 5, 3, and 1. Or this -1. Okay, so that's all you have to do. It's really just change your axis. Okay, maybe the last one. I don't know. So we set this equal to where we normally start sine, which is 4x plus pi equals 0. And so we get -pi fourths for x. So that's where we're going to start, -pi fourths. I need to find my b. So my b is what's being multiplied by x here. So I take that 2 pi original period of sine, divide it by our b, 4. So I get pi halves. And then I'm going to divide that by 4, multiply it by 1/4 to find my interval length. So I multiply that, and I get pi eighths. So I need to switch this to -2 pi eighths. So I have a common denominator, and then I'm going to add pi. So I get a -pi eighths, because I'm at -2 pi eighths, and I add a pi eighths, that's -pi eighths. Add another pi eighths, I get 0. Add another, I get pi eighths. Add another, I get 2 pi eighths. Again, you could take that distance and see that you get a half a pi in between there. Okay, so normal sine, here are the y values for normal sine is 0, 1, 0, -1, back to 0. Now I'm going to multiply them all by my a, which is 2, so that's 0, 2, 0, -2, 0. And then I want to add my c, which is -1. So I'm going to subtract 1 is -1, subtract 1 is 1, subtract 1 is -1, subtract 1 is -3, subtract 1 is -1. So again, you notice these two are the same. And make sure a little bit different on these two, but it's just because we had to add that 1 in there, that -1, which kind of changes things a little bit. Okay, so we had subtract 1, sorry, it's -1, subtract 1 is 1, subtract 1 is -1, subtract 1 is -3, and subtract 1 is -1. Okay, so my lowest number is -3, so that means my lowest point is going to be -3. My middle point is -1, and my highest point is 1. And so that's what that's what my y-axis is. And now I can just graph the same graph of sine. Starts right there, goes up, goes down, and goes back up to the middle. And so all I did was change my y-axis, change my x-axis. The graph still looks the same. Okay. So really, you can do that almost every single one of your graphs, even though if you do this on computer program, that's going to look stretched out and stuff like that. But we can just manipulate the x and y-axis, and that's all you have to do, and your graphs could look the same, except for if we have a negative here, then it just kind of flips. All right, that's it.